So good afternoon, everyone. Am I audible?
Yes, sir.
Okay. So let's start our today's lecture. So our today's lecture, we are going to continue what we have learned so far on our entity relationship model. So in entity relationship model, what we have learned so far is basically what are our entity set. So in entity relationship model, what we are basically focusing upon on our entity set. Then what are our relationship and what are the attributes. So we have also covered different kind of attributes like your single valued attribute, single attributes, simple attributes. Sorry, both are same. Simple and you we have also gone through your derived attribute. Okay, a composite attribute and so on like that. Similarly, we have also gone through the relationship set among these two. So whenever we want to associate two entity set, so for that thing we required a relationship set. So for that thing what we have done, we have gone through different concepts related to your this relationship set. First one is related to your degree. Okay, so we have gone through what is our degree. Then we have gone through what is our cardinality. Okay, cardinality. So cardinality, and through cardinality, what we are doing, we are basically focusing upon first part is related to our, you can say that participation, and second one which we have covered over there is related to cardinality ratio. Cardinality ratio. So in cardinality ratio, we have gone through like one-to-one mapping. Okay, one-to-one, one-to-many, many-to-many, and many-to-one. So this is how basically we have calculated. So how we are basically using cardinality. So cardinality is going to tell us about, so suppose if we are having these such kind of mapping kind of thing, if we are using, so suppose this is my entity set one and this is my entity set two. Suppose this is my relationship. So how many entities? See, how many? So right now for cardinality, we are basically focusing upon the our entity. So how many entities are associated with this relationship set? So as you can see over there, for this example, I must say that it is basically linked with how many? Means every entity is basically associated with only one entity. But what if this entity and from this? So from E2, we can say that the cardinality, the maximum cardinality is what our right now is 2. Why? Because here from this thing, this entity set of E2 is basically participating how many times? 2 times. This is one time, this is one time. So 2 times it is participating. So whenever we are basically calculating our cardinality ratio, we are also always calculating maximum of our cardinality. Okay, whatever the cardinality we are getting it. While in the case of our participation, so participation is divided into two parts. First one is your total participation and second one is your partial participation. So in total participation, what we are basically calculating, we are basically calculating our minimum, okay, minimum cardinality. So if you are getting, so this is very important statement, if you are getting minimum cardinality of that entity set is you can say that greater than equal to 1, then we will say that it comes under the category of what your total participation. Otherwise, if your minimum cardinality is, you can say that 0 is equal to what, you can say that it is equivalent to 0, then we'll say that it comes in the category of our partial participation. So as you can see over there, total participation is represented by two lines. Okay, two lines we need to draw over there. While partial participation is basically whenever if we want to draw a partial participation, then we have to draw only a single link line. Okay, like that. Now in this lecture, what we are going to cover, we are going to discuss about weak entity set. So till now, what we have covered, we have just gone through related to whenever we are discussing about our ER diagram. So in ER diagram, we are focusing upon what thing? Our entity set. Entity set. So we know that what is a entity set. So entity set is nothing but it is a collection of similar kind of entity. And what is your entity? Entity is nothing but it is a any distinguishable object. Okay, it can be tangible as well as intangible. Tangible means it has some physical existence, like student 1, student 2, they are comes under your tangible, you can say that. And your account number of different function person for user 1 as well as user 2. So you will say that these are what your intangible, because they are not physically available. Okay, so as you can see over there, so till now what we have covered, we have just discussed about this entity set. But now what keyword I'm using over there ahead of our entity set is weak entity set. So what do we mean by weak entity set? So just before going through weak entity set, I am just going to cover strong entity set. Okay, so till now I must say that in all the scenario, or in most of the scenario, you have worked where in which kind of entity set? In your strong entity set. I don't think so that till now in any example we have used weak entity set. So what do you mean by strong entity set? So strong entity set is a entity set. Okay, it is a entity set, but that entity set should have a primary key, should have a primary key. So I think you have an idea about what is a primary key. So primary key is basically a set of attributes through which what we are doing, we are basically distinguishing among your different entities. So suppose if I am giving you an example of a student, okay, if I am going to give you an example of this is my student table, and in this student table, suppose this student is table is having only two attributes, your student ID and student name. Okay, so suppose ID is 1 2 3 4, and suppose I'm getting Raj, suppose Shreya, Raj, and suppose Ramesh. Okay, so these four entries, if suppose if I will get these four entries, kindly mute your mic where I'm getting it. Okay. So here in this case, as you can see over there, we cannot make our student name as primary key. Why we cannot make our student name as primary key? Why? Because Raj and Raj, we cannot distinguish among these two student name. Okay, so we cannot distinguish our entity 1. Suppose this is entity 3. So we cannot distinguish among our entity 1 and entity 3. But what will be our primary key? Our primary key is basically a column through which what we can do, we can easily identify our each entity. So in primary key, our main thing is that it should be not null, it should be not null, and it should have a unique value. So suppose if you have created student ID as your primary key, so in future, if suppose some student again, suppose Raj is again entering his or her his data inside this table, so he cannot enter it. If suppose with the same ID, for example, with one ID, if again he is going to enter his or her data, his data, for example. So he cannot. Why? Because it should be unique, and we cannot make it null also. Okay, we cannot make it like null and Raj. It is not at all possible. So that is why our main task is that, whenever we are creating any entity set, our main task is to create focus upon once we have created entity set and we have an idea about our what are our, you can say that, our attributes. Our second task is basically go for to figure out our primary key. So primary key, how we are going to select primary key? It depends upon your database designer. So as I've told you, like there are primary key is a subset of what your candidate key. So you will find, like for example, 4 or 5 keys. I have given you that example. So in that example, you have seen like there are three candidate key, but out of which the database designer is going to select only one key, and that key is known as what? Your primary key. So in your strong entity set, you have a primary key. So whatever the example we have covered or we have done so far, in all the problems you have seen, suppose if I have given you course entity, okay, if we have used course entity set, then course CID. So CID will be what? It should be unique, okay? It should be unique. So we have an idea related to that, as you already know that in your subject, each subject will have a what? Different kind of ID. So we can make it as a what you can say that as a primary key. Now second term, now at least you have an idea about what is a strong entity set. Now we are going to discuss about weak entity set. So what is a weak entity set? Weak entity set is an entity set. Okay, it is a entity set. So it is represented by this double, you can say that double rectangular box. So this entity set, which does not contain, which contains attributes, but it does not contain that attribute who is having holding a primary key. So this is known as what your a weak entity set, where you don't have a primary key. Okay, so if somebody is going to ask you about what is the difference between a strong entity set and weak entity set, so strong entity set is an entity set which holds a primary key, while weak entity set is an entity set which does not hold any your primary key. Okay, so this is known as what your weak entity set. So we'll go first a different your you can say that the definition, and then later on using with the help of our example, we are going to see what is our identification relationship set and why we require total participation. Total participation means every entity of this entity set is participating in that relationship. If they are not participating that relationship, then it means there are some problem with this weak entity set. Okay, so we cannot make them participate. So these are the important conditions that if we are basically making any entity set as a weak entity set, then it should comes under your total participation. So it should totally participate in that relationship set. And here we are not going to call it as a normal relationship set. Here we are going to call it as what? Your identifying relationship set. So identifying relationship set is basically represented using, as you can see over here, this double line. Okay. Now we'll go to the through the definition, and then we'll using example we will explain each and every component of our weak entity set, and it is very important. Okay, because a student got a lot of confusion related to what is a partial key, what is your discriminator kind of thing like that. Okay, so we'll see an example. Now, first we'll see the definition. What is a weak entity set? So an entity set that does not have a primary key, so you can directly call it as a weak entity set. Second one is its existence depends on the existence of a strong entity set. So suppose if I'm going to give you a scenario, and in that scenario, suppose you have to create a weak entity set. Let's assume you have to create a weak entity set. So it's not like that you just create a weak entity set and you can perform any sort of operation. So if that set is a weak entity set, then its existence is totally depends upon your strong entity set. So you have to basically create a identifying relationship set using with the help of identifying relationship set. You have to link with a strong entity set. It's not like that any weak entity set is associated with a weak entity set. No, a weak entity set is going to be associated with your strong entity set, and it is mandatory. Okay, now discriminator. So in example I'm going to discuss about this thing, otherwise you will get confused over there if I'm going to tell you about the definition. So later on if you are going to revise it, so you will came to know about what is a discriminator, or sometimes it is known as what partial. So its primary key is created by, so one more important point is its primary key is created by combining the primary key of strong entity set on which weak entity set is existence dependent. So we'll see in an example how we are going to create a primary key of a, you can say that your weak entity set. Because why we are basically focusing upon why we are very much interested in order to create a primary key in our weak entity set, because if we are not going to create any primary key in our weak entity set, then how we are going to basically retrieve our information? because you will get redundant values. So as I've told you, so in example, I'm going to give you. So underline, so this is known as what your, you can say that partial key. So your primary key means this one. So if you are getting anything in your future, okay, in your future, it might be possible you will get this line. So don't just think about it, okay, there must be some printing mistake. Okay, this is not a printing mistake. This means that it is a partial key. Okay, if you are getting dashed kind of thing. Sometimes the student think, okay, oh, this is the primary key. Somehow it might be possible they got some sort of printing mistake like that. No, it's not like that. Okay, yeah. So let's start with an example. So the example which I'm going to tell you over there, and this is one of the most common example if somebody is going to tell you about and explain you entire thing, entire concept related to your weak entity set. That is, suppose you have a scenario. I'm working as an Bennett University. Okay, we are basically creating for a Bennett University. Scenario is that, so in Bennett University, what they want to create a table. So entity set is what? Entity set is nothing but it is a table. So in your lab, if you are working on any table, it means you are basically working on what your entity set, and whatever the insertion you are doing, okay, insert into values, all those things are what your entities. So your tuple, entities, rows, all are same. Okay, never get confused related to these terms. Otherwise, the student generally get confused. What are the entities in our relational table whenever we are creating? Okay, now suppose in that scenario, what they want that they want to create an entity set of employee. Okay, so as you already know that what are the attributes of employee, like employee is having EID. There are many other attributes also, but for here, for this example, what I want to make these things as what my attribute. My name, my this employee is also having age, and in which department it is working. Okay, in our computer science, engineering, CSE, or whatever, in which department it is working. Now this is known as, so if somebody is going to ask you like whether it is a strong entity set or it is a weak entity set, so it is a strong entity set. Why? Because EID, our employee ID is unique. Okay, so employee ID is always unique. So you have an idea like student ID is always unique. So that is why this our entity set is holding a primary key. Hence, we are going to say that this is known as what your strong entity set. Okay, strong entity set. I'm not writing it, but still it is a strong entity set. Similarly, what we have done, we have also created according to them, according to their users requirement. They said ki what you need to do, because we want the information of employees dependent also. Suppose if we want to conduct some sort of functions, as well as suppose if we are providing some sort of you can say that insurance. So in insurance, what happened? The employee and its family are going to be covered. Okay, whenever you are any employee is basically doing any sort of your you can say that your insurance. So what you will do? They will ask you to create a dependent entity set. Dependent entity set. So what this dependent entity set is going to be hold? This dependent entity set is holding name. Let's assume name, age, as well as relation. Three things it is holding: name, age, and relation. So as you can see over there, I can even draw over there. So suppose if I'm having E1 employee, okay, I'm having E2 employee, E3 employee. Suppose E1 is having wife. So dependent are like, for example, wife, okay, wife, and for example, you can say that child one, child two, like that. Okay, it's up to you. Son, daughter, whatever the thing you can use. Child, child. So suppose this employee is having one wife and two child. Those who are basically going to, these are basically dependent of this employee. So what we are going to do, we are going to put this wife and two child entry where in this dependent table. But as you can see over there in this table, is there any attribute who is basically holding a through which we can make it as a primary key? No, we cannot make it. Why we cannot make it? So we will see. Okay, why we cannot make a primary key of our dependent, you can say that entity set. Because in dependent entity set, as I have given you the example, suppose this is a name, this is my age, I'm just writing, I'm using the abbreviation, and this is my relation. So suppose name is, for example, Joy, age is, for example, 25, relation is, for example, your child. I'm just writing child over there. Similarly, Smrita, for example, I'm using this name, 28, again child. So these are the entries of what you can say that our employee one. But as you already do know that in realistic scenario, it might be possible that there is a one more employee, there is a one more employee whose son or whose child name is also Joy, and it might be possible that they might have a same age and having the same relationship. So in that scenario, if you are going to make name as a primary key, no, it is not possible. Why? Because you cannot differentiate among this Joy or this Joy. Similarly, you cannot make it age as a primary key, because as you already know that it might be possible for, because there are n number of employees. Okay, so you will figure it out like, okay, there are multiple entries related to that. Similarly, we cannot also make it a relation as a primary key. Even if we are going to combine for this scenario, name, age, as well as relation, we can also combine these attributes also. So even though you can say that we cannot basically make them as what our primary. Okay, so it is not possible. So this dependent table, in this dependent entity set, what we are doing, we don't have any primary key. So what we are doing, once you are going to, once you have realized that, okay, this entity set is not holding any primary key, so what you will do, first thing that comes into your mind is make it as weak entity set. Okay, so this is known as what your weak entity set. So you will make this entity set as what your weak entity set. So now you have made this entity set as what your weak entity set. Now after that, what you want, you, because as I've told you over there also, that in your weak entity set there is a partial key or discriminator. Okay, there is a partial key or discriminator. And what is a partial key, what is discriminator over there? So here in this case, we are going to make name as a, you can say that for this scenario, name as a, you can say it as a partial key. Why we are making it as a partial key, and why we are calling it as a partial key? Because for a given entity, not entire entity set, okay, for a given entity, like for E1, I can distinguish my child, my wife, because they don't have the common attribute. Yeah, there is a worst case scenario also, like your wife name as well as your child name will be same, but the chances will be very less. So for our current scenario, what we are doing, we are going to make name as a partial, you can say that partial key. If you are thinking that it might be possible that name of us in a single family can be same, then what you do, you can combine name and age and make them as a, what you can say that as a partial key. Okay, then in that scenario, name as well as age will be your partial key. Then I think these such kind of scenario will not arise, even though if your father name as well as your son name is same in that scenario, but their age will be differ. Okay, so in that scenario, suppose for an employee there is a father name, again his father name is Joy, let's assume, but his age will be like, for example, let's assume 56, and here the relation is father. So if we are going to make name and age as a primary key, so you can see over there Joy 25 as well as Joy 56, both are what, different. Okay, both are different, so hence we are going to make it as well as a primary key. Now we have an idea about this partial key. So for our scenario, for our best scenario, we have just think of like in a family, in a single family, or in a for a single entity, whatever the dependent, whatever their dependent are, 2, 3, 4. So all those are basically having a different name. So within a same entity, I can distinguish among those entities. But within an entire table, I cannot distinguish it, because For an employee to, it might be possible that I have a Joey 25 child. It might be possible I'm having the same values like that. Okay. So that is why we are not going to call it as a primary key, but we are going to call it as a partial key. Also, we are going to see about the functionality of partial key later on. Why I have make this thing as a partial key. Okay. Now, once I have created this thing, our next task, and well, as I have told you, like whenever you are, this point is important, its existence depends on the existence of a strong entity set. So without existence of a strong entity set, we cannot create a weak entity set. Why we are not creating any weak entity set? Because as I've told you, because in future someone might ask you about that question, that why it is always dependent on our strong entity set, why you are not making it as a weak entity set, as a independent thing like that. So you will say that because how we are able to distinguish among the entities, if we want to access the data of Joy, so which Joy I want to access, I will get these. So suppose if I want to information of this Joy, so I will get this Joy also, so I will get all the Joys information related to that. Okay, so I don't want like that. I want a specific values. I don't want redundant values. Okay, so as I've told you, like redundant will leads to inconsistency. Okay, and it is a very major problem if your data is having a redundancy, and if you are getting some sort of inconsistency in your data. Okay, now for that thing, that is why what we will do, we will always create a, you can say that a identifying relationship set among your weak entity and your strong entity. So what we are going to do, we are always going to create it. So through this mapping example, I'm going to explain you each and everything. Suppose I'm having employee E1, E2, E3, E4, E5, and E6, and so on. Okay. Similarly, I'm having these relationship written like that, and I'm having dependent D1, D2, D3. I'm just writing like that. Okay, I'm not using name. D4. These are the names. Let's assume D1 is the name of your dependent. Okay, so it might be possible. It might be that we are repeating these values. D1, D2, D5, like that. Okay, so for first employee, it is this one. These are three dependent of my first employee. Similarly, from second employee, we are having only one dependent. For third employee, we are having one dependent. For fourth employee, we are having also one independent. And for fifth, we are having only one dependent. Let's assume this is a scenario. Okay, I'm just mapping it. In realistic, it might be possible or not. But for my E6, because it might be possible that there is an employee who does not have any dependent. Okay, it might be possible, while in realistic it is not possible, but we are assuming it, that it might be possible, like for example, this employee doesn't have any dependent. Okay, doesn't have a dependent. It means that this E6 is not participating in this relationship set. Okay, it means this dependent is not participating in this relationship. And what are E1, E2, E3, E4, E5, E6, so on? These are nothing but, you can say that, our primary key. Let's assume these are my primary key. These are what my partial key. I have made partial key as my name and a primary key as my EID. So this is all about this thing. Now why I have used this identifying relationship? What is the reason why I have used identifying relationship? Because through this identifying relationship, what we are going to do, our main next task is, in order to identify, in order to distinguish among this D1 and this D1, how I will be able to distinguish it, what I will do in entity set, I am going to merge. What I will do, I will use the primary key. I will use through this relationship set. What I will do, when we are basically converting our ER diagram to our relational table, then you will be able to understand each and everything in a very clear manner. Okay, but still I'm able to, I'm just going to explain you that what we will do in order to make it differentiable. What we will do in our weak entity set, in our weak entity set, we will make it as a combination of our primary key. Our primary key will be combination of our EID, our employee ID, as well as our, you can say that, name. Okay, so name. So this will be our name. So now you can say it like that. Now we can distinguish among our D1 as well as my this D1. Why? Because now my key will be D1 E1 and D1 E4. And as you can see over there, D1 E1 is different from D1 E4. Now, second question that comes into your mind is, sir, it's better we will make this primary key over here. Can we make this primary key, just this employee ID primary key over here? No, we cannot make it. Why? Because as you can see over there, E1, E1, E1. Okay, so as you can see over there, we are getting redundant values. Why? Because D1 is dependent on E1, D2 is dependent on E1, D3 is dependent on E1. So we cannot just make this primary key as a your employee primary key in your dependent as a dependent primary key. So how we are going to make it? We are going to combine partial key. So that is the main role of your partial key. So that is why partial key is going to help us in order to distinguish within a entity. Okay, within that entity. So that like D1, D2, D3. That is why. If suppose if I'm getting D1 over here, so we cannot make it this thing as a partial key. Okay, so we cannot make this thing as a partial key. But here everything is different for that particular entity. Hence, what we are going to do, we are going to make it as a your different entity. Okay, your partial entity. So this is known as what your partial entity. So based on our you can say that what knowledge what we have learned so far, what is the degree of our this thing? So degree will be what your 2. Why? Because 2 entity set is participating. Okay, don't assume it like weak entity set is not an entity set. You have to consider it. Okay, so for this identifying relationship, what is the degree? What is the degree of this identifying relationship? 2. Why? Because 2 entity set are participating. Now, what is the cardinality maximum? I am talking about maximum cardinality of my this what employee table. So maximum cardinality of my employee table is what? 1. Maximum cardinality of my employee table is 1. Why? Because we don't have 2-3 employees with the same name. Okay, we have only one employee. Okay, so that and every employee in this relationship set is participating, or how many times it is basically participating. Sorry, here your cardinality is sorry. Here your cardinality is, for example, 3. Why? Because your E1 is participating how many times? So cardinality again, so those who are having some issues related to your cardinality, I am again repeating, cardinality is that the number of times that a particular entity is participating in this relationship. So as you can see over there, E1 is participating 1 time. This is the second time it is participating with this entity, and this is the third time it is participating this entity. So the cardinality of E1 will be 3. What will be the cardinality of E2? 1. Cardinality of E3 will be 1. Cardinality of E4 1. Cardinality of E5 will be 1. What is the cardinality of my E6? Because it is not at all participating in any relationship. Hence, what we will do? We will make it as what? 0. Okay, we will make it as 0. Now, in case of whenever we are basically calculating cardinality ratio, so cardinality ratio over there, we are basically focusing upon maximum of your cardinality. So from this set, what is the maximum cardinality you are getting it? 3. Okay, 3 comma max function. If you are going to apply 3 comma 1 comma 1 comma 1 comma 0, so the maximum value which you are going to get it over there is 3. So from employee point of view, if I'm going to create a ER diagram, as I have already told you, so suppose this is my this thing. Okay, and this is my weak entity set, this is my employee, and this is what my you can say that dependent. Okay, so what will be the my you can say that the cardinality here is 3. Similarly, can anyone tell me like what will be the cardinality of this thing, my this dependent entity set? In the chat box you can tell me. What will be the cardinality of my maximum cardinality? Okay, I'm asking about the maximum cardinality of my employee entity set. So yes, so the answer is 1. So 1 is correct. Why? Because as you can see over there, D1 is participating how many times? Only one time. D2 is participating how many times? Only one time. So every dependent is participating how many times? One time. So from here you will see that this is 1. So, but as you already know that here we haven't mentioned in our entity relationship diagram that an employee can have at most 3 dependent. Okay, we have said that as many dependent as many. Okay, so in that scenario we will make it as what? N. N is nothing but any value. Okay, so that is why whenever you are going to draw it, so what you do, you just swap it. Okay, so each employee will hold many dependent. Okay, make it as N. So it means that each employee is holding many dependent. So now you have worked upon this, your cardinality ratio. So now second term is what? Your participation. Second one is your participation. Why I am repeating again? So that you can also you should understand the concept of weak entity, as well as you should have an idea about cardinality also. Okay, because this is very important concept. That is why I'm taking a lot of time. Okay, so this is known as participation. So participation, as I have told you, there are two types of participation: total as well as your partial. Okay, in my previous slide I have told you like there are two types of participation. First one, I think I have erased. Yeah, this one. Sorry, I have erased that part here. So total participation as well as your partial participation. Okay, now how you are going to calculate your participation? Participation you are going to calculate using your minimum cardinality. Your minimum cardinality. So you have calculated this cardinality. Okay, now can anyone tell me what is the minimum cardinality of my employee table? What is the minimum cardinality of my employee table? Anyone? Just post your answer. Yeah. So I got 0. Is there anyone who is getting some different answer? Okay. Okay, so everyone is giving me the correct answer. So here our cardinality is minimum cardinality is 0 minimum. Okay, so if you are going to use min of I think you have an idea 3 comma 1 comma 1 comma in your Python as well as anywhere, if you are going to execute the output which you are going to get it over there is 0. Okay, so here my minimum cardinality is 0. So for employee my minimum cardinality is what? 0. What about dependent? What is the minimum cardinality of my dependent? Can anyone tell me what is the minimum cardinality of my dependent? Just post your answer. Minimum cardinality of my dependent. So as you can see over there, D1, D2, for this example, I'm just asking you about, okay? D1, D2, D3, see, as you can see over there, every entity of this entity set of my dependent entity set is participating in this process, okay? So what will be the, you can say that minimum, so minimum will be 1. So that's great. So minimum, you can say that our minimum which we are going to get it over there, cardinality which we are going to get it over there is 1. Why? Because minimum of, because for every, you can say that every key, every entity is basically participating here. So if you have a dependent, okay, so if you have a dependent, so it should, if you are making an entry of any dependent, so it should have a linked with any employee, na? So it is mandatory. It might, but from here it might be possible that a employee cannot have a dependent. But is it possible that a dependent cannot have any employee? No, it is not like that. No. So because our through employee we are basically accessing our dependent. Okay, so it is not at all possible. So hence minimum of 1 comma 1 comma 1 comma 1. The output which you are going to get it over there is 1. So as I've told you, so this is a mathematical expression I've told you. Whenever you are getting greater than equal to 1, okay, greater than equal to 1, your cardinality, okay, your minimum cardinality, if you are getting it greater than equal to 1, then it is a total participation. And if you are getting it equal to 0, then it means partial participation. So here in this case, as you can see over there, from employee point of view, what we are getting? We are getting value 0. Hence, from this side, we are getting partial participation. So partial participation is a single line. Okay, it is a single line. But from a dependent point of view, what is this? This is a, you can say that it is a total dependent. Why? Because here we are getting the cardinality as minimum cardinality as 1. So when your minimum cardinality is satisfying this condition greater than equal to 1, so hence we are going to make it as what? Your total participation. So for total participation, we are going to call it as, we will use what? Double line. So this is what you need to draw in your ER diagram also. Whenever we are giving you any questions related to that, this is how you need to draw it like that. Okay. Now we'll see this example. So see, now this is how we have drawn. So that is why I have explained you each and everything over there, so that at least you should have an idea about your cardinality. I don't want that after that, after this, once we are going to complete our entire lecture, we'll say, okay, we can make n here, m there. So we should have a exact, we should know the logic behind that. Okay, just don't say it like it will be 1 ratio and 1 to many, many to 1, like that. Okay, so you have to use it. Why we are saying it as 1 to many, many to 1, like that? So based on that, you should have an idea related to that. That's why I have repeated this part. Now, so this will be our example. As you can see over there, employee has dependent. We have an idea. So as you can see over there, name is our weak relation, this thing. So I have entirely explained each and everything. So this is my strong entity set and this is my weak entity set. Okay. And as you can see over there, this is my total participation. And never ever forget about this thing. Okay. Here you are getting identifying relationship. So in identifying relationship, what you are doing, you are picking the you are merging, basically I must say that you are merging your primary key with your partial key. Okay, so whenever we are going to convert our this ER diagram into your RDBMS, then we will see. Okay, so most probably tomorrow in the evening I'm going to conduct one class of yours. So maybe if it is possible, then I'm going to explain you that part also. That part is quite simple. It's not that much complex. Okay, so if you have an idea, entire idea about this ER diagram, then you can directly map it. Okay. Similarly, we are also having one more example. That is, if we are having loan and we are having payment. Okay, so payment is basically dependent upon your loan. Okay, okay, don't get confused. Like in some of the your book, you will get this sign also. Okay, so this sign, what does it mean? This sign means one. Okay, as you are getting the one to many. So if suppose this it might be one to many, so in some book what they will do, they will use this sign. If they are using this sign, it means this is a one side, and if they haven't made anything over there, so it means that is a many side. Okay, so I'm just telling you, like if in future you came to know about this sign, so don't get confused that what is this? Is this a direction? No, it is not a direction. It is a telling. It is telling us about the cardinality. So in cardinality, if you are getting this kind of sign, so it means one side relationship. One loan can have many payment like kind. Okay, so as you can see over there, a loan can make many payment. Okay, so similarly, we have make this payment as payment weak entity, because it might be possible like different loan can have a same payment number. Okay, so that is why we have made this as a you can say that weak entity set. And as you can see over there, here we are having loan number. So this is my strong entity set. So without loan, our payment cannot exist. Okay. So without loan, can you our payment exist? No, our payment table cannot exist. Hence, what we will do, we are going to draw this your total participation, and then after that we are having this partial participation like that. Okay. So this is all about your weak entities. Now, similarly, one more example is related to your weak entity set. Example continue like your, if you are having book contains. So see, always in most of the scenario, you know about that student ID will be what your you can say that unique. But sometimes what happen, in order to make problems complex, what they do, they give you some sort of problems. Okay, the problem will be like in your school. Okay, in your school, can I make roll number as a primary key? In your school, I am telling, not about your 10th exam or 11th. In your, suppose if you are studying in your 6th class. Okay, in your sixth class. I have no idea about your roll number, but in my case, I will tell you about that part. In your if there is a student having some roll number, can I make roll number as a primary key? Anyone?
No, sir.
Yeah. So we cannot make this thing as a, because as you already know that we are having different sections, okay, A, B, and C. So over there, I think in during my time, the roll number will be always 1, 2, 3, 4, 5, so on. Like for again in B section also we'll have a roll number 1. In C section we also have roll number 1 like that. Okay. So in that scenario, we will not going to make roll number as a primary key, but we can say it like, suppose if our situation is some like that, somehow like that, so we can say it like, okay, it is a partial key. Okay, we'll call it as a partial key if we are basically creating any kind of, you can say that, entity set related to that. Okay. So as you can see over there, one book can have many chapters. Okay. And similarly, chapters are without chapters. So chapters are totally dependent on book. Okay. So without book, if we have a chapter, then we should have a book also. So they are entirely, their existence is totally dependent on your strong entity set. So this is how you can create it. Okay. So now there are some MCQs. So just tell me, so what you have learned so far. So weak entities and their identifying relationship in the ER diagram are represented by, just tell me about just A, make it as A, B, C, D, okay? A, B, C, D. So what will be the output? And your weak entity set and their identifying relationship in the ER diagram are represented by, yes, give me the answer. Yeah, let me open your chat. Yeah, so I got one answer from Pranjal. B, is there anyone who is getting some different idea?
Sir, it is
Answer?
showing chat disable.
Sorry?
It is showing chat disable. Administrator has declined chat for one or more users.
Yeah, I think I have to call this IT cell related to that. Now, from my end, it is showing. Even from your end also, it is showing because some of the students are basically posting their meeting chat. So I will contact IT team. I think it might be possible
The
they might have.
recording tools are not being stored in online. They are just
Yeah.
available.
Actually, what have the, I think in IT people, I think they have make some sort of changes over there. Okay. So what, even though if I'm going to stop my meeting, this thing recording, then what will happen? It is going to be, so what I need to do again, from now, what I will do, I have to follow that procedure, that first I have to download that video, then I have to upload it. Otherwise, in earlier case, automatically that thing is happening over there. Na? But nowadays, what is happening? I have to download that video and then again I have to upload it. So what about in other subject? Because I have no idea about other subject. In other subject also, this thing is happening nowadays because it's been like from the past 2 3 days. Are you able to see the you can say that recording of other?
No, sir, सब में same ही है.
सभी में सेम आ रहा है ना? हाँ, तो ये आईटी टीम का आई थिंक कोई इशू चल रहा है. तो विल
Okay,
कांटेक्ट
sir.
देम, अदरवाइज मैं वही करूंगा कि डाउनलोड करके आई विल अपलोड इट ऑन माय एमएस स्ट्रीम, या फिर अगर मुझे लगा कि बिकॉज यूट्यूब में साइज कम रहता है तो यूट्यूब में अपलोड कर दूंगा. ओके.
Okay, sir.
Okay, so the answer which all of you have given me, the correct answer, the answer will be what? Your B. No, sorry. Question is what? Yeah. So all of you are giving me what answer is? You haven't understood the question. I'm not asking about the entity, weak entity set. I'm asking weak entity and their identifying relationship in the ER diagram. So identifying relationship is, you have to find out. Okay. Yeah. So the answer will be what? D. Yeah, that's it. Now the entities that have key attributes to be distinct are considered as weak entity, strong entity, single entity, or foreign entity. I think all of you have now have an idea about what are these entities. So yeah. So Raghav, why you have posted D option? Even Vansh have also posted D option, foreign entity.
Sir, because key in a table can act as a foreign key, that's why it may be foreign entity.
No. Foreign. We are talking about entity. Do you have? So what is foreign entity? I'm not talking about the key. I'm talking about the entity. Okay.
Okay, sir.
So
Okay.
if any entity have a key attributes, okay, to be distinct, it means you are able to distinct. So even with the help of foreign key, also you are not able to distinct that entire table also. Okay. So that is why it is not a foreign key. So the answer will be what your strong entity. Now the parent entity type or identifying entity type are considered as other name of your dominant entity type, your non-dominant, your composite entity type, or your. So I think from this thing, I think you can tell me about, because I have told you about the existence of a table like that. Okay, so what will be the answer? The parent entity type, why I haven't covered this part, but still on the basis of existence, which I told you over there, you can now tell me about that. The parent entity type or identifying entity type are considered as other names of dominant, non-dominant, composite, or entity. So yeah, so the answer will be what? Dominant entity type, because it is dominating over there. Okay. Similarly, the key set of key attributes that identify weak entities related to owner entity is classified as your structure key, partial key, string key, or your foreign key. Okay, for a weak entity set. Okay, for a weak entity set, if there is a key, so it will be what your partial key. So now I think you should have an idea about what is a partial key. So in future, if somebody is going to ask you about and you have to create partial key, so don't get confused, because in book you will came to know about the definition, like partial key is also used to find out the distinct. It is also used to find out the like different entities in a distinguish among the entities also, like that. Okay, no, it is not going to distinguish all the entities. It is going to distinguish a particular set of entity. Okay, not the entire entity. Okay, so I think our time is over. So on Saturday, first of all, I'm going to tell you about EER model. So I think this model, I think if you have an idea about entire what is entity, what is relationship, what is entity relationship model, what are attributes and so on. Now in EER model, what we are doing, we are basically using the concepts of our object-oriented programming language. Not the entire concepts, but some of the concepts we are going to use, mainly your inheritance. Okay, inheritance. So why we are using EER model? So we are going to discuss in our tomorrow. Tomorrow we will have a lecture, I think at 5 to 6. I'm going to create a meeting, okay, at 5 to 6 during that session, 5 to 6 or 5 to 6:30 based on that. So if you are interested, then I can also cover one more topic, that is how we are going to convert our ER diagram into your relational table diagram. And for I think, because I have also got something from your end that you want that there should be some sort of problem solving classes. So as you already know that during lectures we cannot conduct these such kind of classes. So and in this subject we don't have tutorials. So that is why in every Saturday, if students are having some queries or doubts, so we can conduct a session. We will give you some sort of questions related to that. And those who are interested, it is not mandatory for to join that session. But those who are basically interested in order to solve these such whatever the problems we are giving you, so they can join or attend that session. Okay, so in every Saturday, because I think Monday to Friday you are all busy from 8:30 to like your 5:30. So that is why I want to conduct that tutorial kind of session when on Saturday, so that your doubts will be cleared. Because I think from my end, I must say that tutorial is very much required for this subject. Okay, so that is why I also want that I should give you some problems, and you just try to solve those problems, and we'll have a discussion based on that. Okay. Okay, then thank you all. So see you tomorrow. So any doubt till now?